In this video, I'm going to be showing you how to solve the TJCTF problem weird audio circuit, where they give us this audio file, which you can download here. It's a .wav file, and then we're just going to open it in Audacity and see if there's any hidden messages. So when we open this up on Audacity and hit play, it sounds like there's a high-pitched noise and somebody trying to talk on top of it. So my first thought, generally with these problems, is to check the spectrogram, which you can just go to the view of this and go spectrogram. Then see if there's a message that's basically written in the frequency component of the signal. So let's move up to where it looks like there's some data, and it doesn't look like there's anything written here, but this looks just like, to me, AM modulated audio in the frequency domain, where it's scattered about 3 kilohertz to either side, and we have this seemingly a carrier wave at 10 kilohertz. So my next thought was, this is probably just AM audio modulated with a carrier frequency of 10 kilohertz. So if we can demodulate this, we should be able to get the message back. Now, I thought there might be an effect for this in Audacity, but there's not, at least not directly. So we're going to have to learn a little scripting in the Nyquist language. So I did some Googling and I found somebody else's code to demodulate this at 8 kilohertz. So I just took this line of code and changed it to 10 kilohertz and applying a low-pass filter and then shifting it down and demodulating as AM. So we just take this code, but we want to apply a custom filter. I didn't know how to do that. Just did a quick Google search, and turns out we can go Effect, Nyquist Prompt, and then inject our own Nyquist code. So we copy and paste my modified line to treat it as a carrier at 10 kilohertz. Go over to Effect, Nyquist Prompt, after hitting Control A to select the audio. Nyquist Prompt, paste in our code, hit OK, and we can see that these frequencies have all shifted. So if I zoom back out, now it's centered around 0, and if we go back to view it as a waveform, that looks a lot more sensible. Now you hit play,
correspond to the sounds to be reproduced by a loudspeaker.
and that sounds like normal audio. The flag was in here 40 some seconds.
The flag is TJCTF left curly bracket Y0 UTA.
And that's a little fast, but I've transcribed it here as this you thought and then a bunch of letters. So there it is.